Alright, so what I have as notes is, we really didn't need to write out this much, but so I have it written out, I did. And it also reviews some stuff from a while ago, which is nice. So, chapters and chapters ago, we had rules for combining two random variables. So, let's say that we're dealing with, I just picked two letters, random variables W and L. We have different rules for combining them. So when I am finding the mean, and I am adding the two random variables, so my mu of W plus L, how do I find that? And when I'm subtracting them, mu of W minus L, how do I do that? How do means work? What's our one rule with how means work? Exactly how you would expect them to work. So what is this?
Mu of W minus mu of L.
So means always combine exactly the way that you think they would. So when we're supposed to be adding the two, we just take the means and add them. When we're supposed to be subtracting the two, we just take the means and subtract them. Now that was not the case when we moved to standard deviations. So we had two rules for combining when we're dealing with standard deviations. What's one of them?
Always add.
Always add. So you can't ever subtract, because taking a standard deviation of 7 and a standard deviation of 5 and all of a sudden having a tiny standard deviation of 2 doesn't even make sense. What else?
You can only do it in the state of variance.
You can only combine in the state of variance. So you have to convert them to variances and then combine them and then bring it back to standard deviation. So if I am finding the standard deviation of W plus L, well, I have to add them. How do I write the variance of W? What does it look like? Sigma W squared. How do I write variance of L? Sigma of L squared. And then I take the square root of all that because I still want a standard deviation, and right now it's variance. So when I am subtracting W minus L, what do I do? It's still the exact same thing because you can only add, you can't ever subtract. You still have to combine through variances. So whether we're adding or subtracting, we actually do the same thing with standard deviations. So all that was reviewed from chapters and chapters ago. Now, we're going to deal with means and proportions, tests, and intervals all this chapter. But today I'm going to start with intervals. So, chapter 8 with intervals, when we were dealing with proportions, our whole goal was to estimate what? To estimate what? So we had to use P hat instead of P, because we didn't know it, in the standard deviation portion of the equation. And anytime we use a statistic in the standard deviation portion of the equation, we call that what? If we're doing this and using a statistic instead, that is called standard error. All this is just kind of review stuff.
I'm not really good at seeing it in the words.
This is a bit of an overkill, but I'm making you write all this out. So, like, you just need to be okay following with it right now. So in chapter 8, what was our equation for the standard deviation portion of that equation? Knowing that what I just said, that I had to use p hat instead of p. So now I'm taking this from chapter 8 and now applying the fact that we have two different samples. And combining that with everything we just did in the top. And like I said, this is a bit of an overkill, but it helps to go over all this stuff while we can. Alright, so now that we're going to have two samples, things that go in this equation, now I'm going to have a what? Because I have two samples. So am I just going to have a p hat? I'm going to have what instead? P hat what? 1 and p hat 2. Now I'm saying p hat 1 and p hat 2, and you can always use p hat 1 and p hat 2, but sometimes it helps to actually do letters there instead and do it context specific so that you can remember which one's which. Like for dealing with males and females, I would do N and F instead of 1 and 2, so I don't have to think back every time about which one's which. So what else from the equation am I also going to need a 1 and a 2? From this equation. N. So I'm going to also need an N1 and an N2. So for sample 1, the standard deviation is square root of what? P hat 1 times 1 minus p hat 1 divided by N1.
Why do we have the N one and stuff?
Because we are getting ready to start this chapter with two separate samples. So then in sample 2, it's going to look the same thing except what's instead? 2. Now I'm going to have p hat 2, 1 minus p hat 2 over N2. So this chapter we are going to be dealing with combining. We're actually going to always be dealing with the difference. So we're always going to be subtracting. But applying the rule that we just said here, I am now going to apply that to these. So when I combine these, I can only combine through what? Variance. What's the difference between variance and standard deviation?
Variance is standard deviation squared.
So what do I get rid of here? So the variance of this is just right? The variance of this is just without the square root. And even if I'm finding the difference, I have to do what in between? And now do I leave it there? Because right now it's variance, but I want a standard deviation. So that's the background of why this is now going to be for this chapter our equation for standard deviation when I'm combining two. So we just connected the things that got us there.
Yeah.